Hello everyone, I am going to explain question number 5 from exercise 3.5. This question belongs from 10th class maths. If the roots of quadratic equation is given here, are real and equal, then prove that 2b is equal to a plus c. So for this quadratic equation which is given here, the roots are real and equal are given to us, and with the help of this condition we have to prove that 2b is equal to a plus c. So first we are going to find out the condition for real and equal roots. So we'll start like this. First we'll write down the given equation. Here given equation is b minus c x square plus c minus a x plus a minus b equal to 0. Now this quadratic equation first we have to compare with the standard equation of quadratic. So we'll write here on comparing with, now we'll take ax square plus bx plus capital C equal to 0. Actually in the standard form here small a, small b and small c we used to write, but small a, small b, small c equation is already used. That's why I am not using here unless we will get confused. That's why. Now when we want to compare it, capital A is the coefficient of x square, and what is the coefficient of x square here? B minus c. So capital A is equal to b minus c, and capital B is equal to c minus a, and capital C is equal to a minus b. So we will compare it and we will write down the values of all these coefficients and constant. So we will get here capital A is equal to bracket b minus c, and capital B is equal to bracket c minus a. In the same way, capital C is equal to a minus b. Now it is given that this quadratic equation have real and equal roots. So that condition we have to write here. Since given quadratic equation have real, let me see what's the condition actually, real, distinct or real equal. I have to confirm it, real and equal. So we'll write here have real and equal roots. So in that situation discriminant is equal to 0. Now what is the formula of discriminant? B square minus 4ac equal to 0. So it's available to us. So for real and equal roots, discriminant equal to 0. It's a formula, and in that the discriminant formula is b square minus 4ac. Now here we have to put the values of b, a and c. So what is b? Bracket c minus a. So we'll write here b's value and a's value and c's value I have to write here. So that is going to give us the next line. So capital, on replacing the capital B's value, we will get here c minus a whole square minus 4 multiplied by a. A is b minus c and capital C is a minus b equal to 0. So see here what we have done here. Capital B value is c minus a. So I replaced here c minus a. Then minus 4, there is no symbol, means they are in multiplication. A's value is b minus c and capital C's value is a minus b. Now we are going to solve this. Here first I am going to open this bracket by using a minus b whole square formula, and here also this bracket I am going to open. So we will get here like this. Firstly, because I am going to use the formula here, x minus y whole square, that is x square plus y square minus 2xy. So I wrote the formula. Now when we use this formula here, it is going to be c square plus a square minus 2ac. Now this minus 4 I wrote as it is. Now we need to open these two brackets also. So what is the method to open the two bracket? First term from the first bracket multiplied by the second bracket, then second term from the first bracket and multiplied by the second bracket, bracket close equal to 0. So what we had done here, I had opened this bracket, c minus a square I opened with the help of x minus y whole square. That gave us, instead of x square we have c square, then plus y square, then minus 2 xy value is minus 2ay. This minus 4 I wrote as it is and they are in multiplication, so I use here big bracket so that it will come in multiplication. Now we have to open these two brackets also. So how to open the brackets? First term just write down from first bracket, with that attach it and then write down minus c here and attach this bracket also. Now open them. So when you have to open, you have to get it as c square plus a square minus 2ac, then minus 4 as it is, minus 4 as it is, and here when you will open the brackets you will get here ba minus b square minus ca plus cb, then big bracket close equal to 0. So what we have done here is these three terms I wrote as it is, then minus 4 as it is. With b I multiplied both the terms and with minus c also I multiplied both the terms so that small bracket can be moved. Now here we will see whether we have any like terms or not. So all are different from each other. There is no like terms. So we cannot add and subtract them. That's why we are going to open this big bracket also by multiplying all these four terms by minus 4 one by one. So we are going to get in next step c square plus a square, then minus 2ac minus 4ba, then plus 4b square plus 4ca, and then minus 4cb equal to 0. Now after this we will see whether any like terms is there, then we have to simplify it. So this is AC and this is CA, so they both are like terms, and except these two all are different from each other, so only these two are like terms. I am just making a curve so that you can understand. These two are like terms because they have the same variable. The remaining all are the different terms. We cannot add and subtract, so write them as it is. Square terms I am writing in initial places, so it is going to be c square plus a square plus 4b square. I am just shifting in front, and the curved terms, that is this minus 2ac and plus 4ca, when we will add or subtract them, so it's, they have opposite signs, so we have to subtract, and sign of big number, so it's going to be plus. So it's going to be plus 2ac and then minus 4ba, then minus 4cb equal to 0. So student, we have now here three terms with the power 2 and three terms which have two variables but their powers are 1. So it can be in the form of a plus b plus c whole square. So that I am writing here which formula I am talking about. The formula is a plus b plus c whole square, and its answer is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Because in this formula the first three terms have square power and the remaining last three terms have both the variables with 1 as power. So these six terms we can arrange in this format. Now how to arrange it? It's very important step, so understand properly. These last two terms have negative sign. Now among them which variable is common? Among them b is common. So this b is going to be negative. So we are going to write them in the power of square. So it's going to be like this, student. C square plus a square plus minus 2b square. Now why I among all these three, why I took minus sign in this only? Because whatever negative term appeared in them, b is common. Since b is common, so b term is surely is going to be negative. That's why I put here minus sign. Now here we are going to write them in the form of 2ab, 2bc and 2ca. So it's going to be plus 2 multiplied by a, then multiplied by c, plus 2 multiplied by a, then multiplied by minus 2b, then plus 2 multiplied by c multiplied by minus 2b equal to 0. Now why I just see here, I not change them. 2 into a into c is 2ac. If you multiply it, you will get again minus 4ba, and if you multiply these three terms, you will get again 4 minus 4cb. So the same terms I wrote in the form of 2ab, 2bc and 2ca. So since all these three terms, all these 6 terms are in the form of these 6 terms, so conclusion is these 6 terms answer is a plus b plus c whole square. So we are going to write here c plus a minus 2b whole square equal to 0. Now why I wrote it? Why I wrote this formula? Because of this reason. So this formula is very important for this step, so you must write it. Now in next step, this square will shift in other side. So square root of 0 is 0. So we'll write here on taking square root, on taking square root, we get c plus a minus 2b equal to 0. Now from here, this 2b is shift in other side, so you will get c plus a is equal to plus 2b, and further which we can write as, and the same thing you can write as 2b is equal to c plus a, and this only we have to prove, so we will write down finally hence proved. So it's completed. So in this question, the use of formula of a plus b plus c whole square is very important. So carefully just use that formula, and further if you have any problem in any step, you can write in the comments so that I can explain it again. Thank you.